Hello everyone, this is Group 9 reporting for priority scheduling. So, why did we use priority scheduling compared to other 6 CPU scheduling? The first reason is easy to use scheduling method. Processes are executed on the basis of priority, so high priority does not need to wait for long, which saves time. It's all about, it simply means that for easier terminology, the higher the priority, the first one to be executed. The lower the priority will be the next one. So next, this method provides a good mechanism where the relative importance of each process may be precisely defined. Also, this priority scheduling is special among them because this can perform preemptive and non-preemptive. Later, we will discuss what is preemptive and non-preemptive in priority scheduling. But priority scheduling have met some major problems according to our research because it causes indefinite blocking. When the process is ready to run but waiting for CPU can be considered block. Can leave some low priority process to wait indefinitely simply means that it will starve to wait for CPU's recognition after all the process from the high priority up to the lower priority. Just think about this. In Filipino, natatambakan siya. Kapag ang isang process ay natambakan ng mas mataas na process ng mas mataas na process, ang ibig sabihin, yung process na nasa ibaba is magi-starve siya. Hindi siya makakaangat unless maubos lahat ng priority na nandito sa taas. So, nagawan siya ng solution using aging, where it means a technique where the low priorities will be increased gradually where the process that wait in the system for too long. So, the aging will not let process to starve for CPU. So, the priority increase gradually. So, ulit sa Filipino explanation, i-explain ulit natin. Di ba ang sabi ko kanina, yung mababang priority, matatambakan siya ng higher priority. But because of this solution using the aging technique, it will gradually increase the lower priorities its priorities. So, the CPU cannot give its starvation. So, habang tumatagal siya sa ilalim, yung mababang priority, gradually siyang umaangat. Tumataas ang kanyang priorities slowly, step by step, hanggang makaangat siya sa pagiging tabon, kaya hindi siya matatabunan. Kumbaga, yung mga dumarating na bagong priorities ay mapupunta na sa ilalim niya. Kasi tulad nga na sinabi, aging technique, yung nasa baba, tumataas siya ng tumataas habang hindi siya tumatagal. Kaya, ang sinabi dito, so, the aging will not let the process to starve for CPU. Hindi siya hahayaang mabulok sa ilalim. Tataas siya ng tataas, yun ang kanyang simple definition. Kaya, naging maganda ang priority schedule dahil sa aging technique na ito. So, next slide. So, priority scheduling. What is priority scheduling? Priority is associated with each process and the CPU is allocated to the process with the highest priority. Ayun yung in-explain ko kanina, mas mataas yung priority, sila yung una, mas mababa yung priority, sila yung nasa huli. Now, next. So, the process with highest priority will be given the CPU first. And the process with the next priority will be given the next CPU and so on. Process with the same priority are scheduled in FCS or first come first serve. The first process that arrived will be served first. Later in our example, we will have a C++ example in our actual program later. So priority scheduling can be preemptive and non-preemptive. Let's define what is preemptive. A preemptive priority schedule follows. If newly arrived process has higher priority compared to process currently running on the CPU, And then the CPU will be taken away from the currently executing process and be given to the newly arrived process with a higher priority. Basically means it will disturb the current running process if the newly arrived has higher priority. Let's give an example in Tagalog. Kunyari, ito ang process niya, nandito siya, gumagalaw siya, pero may mas mataas na priority yung bagong dating. Ibig sabihin, mas darating siya ay yung preemptive. Mas magiging mas mataas ng priority yung bagong dating ng mas mataas. Gets? Now, for the second, non-preemptive priority scheduling follows. If the new process arrives with a higher priority than the current process executing, then the current process will not be disturbed by the newly arrived process. It will just be kept at the end of the ready queue. So, kabaliktaran niya sa non-preemptive, kunyari, may current na gumagalaw dito. Sa preemptive, di ba, kapag may bagong dating na mas mataas priority, aalisin niyo yung current, papalitan siya ng bagong mas mataas. Pero sa non-preemptive, yung process na gumagana, kahit dumating pa yung mas bago, hindi niya tatabunan yung currently running. So, saan siya mapupunta? Sa likod ng currently running. Bale, susunod lang siya sa ready queue. Just like in this, it's stated will not be disturbed, but the currently new arrived process just will be kept at the end of ready queue. Hindi niya i-disturb yung currently running compared to preemptive. Now, here is the C++. We use this language to create the program because C++ is easier and faster, and most of my teammates already know C++ and can program on C++. So, let's go to the program.
So hello again to our C++ program. So here let me paste the source code here. Here are the source code, but we are going to skip looking at this discussing because we are now going to input terminal to make our time shorter. So if you press run, the program will ask for our input of the number of process for prompt. Let's say the number of prompt is 5, basically means from P1 to P5. Enter the arrival time of process for P1. Let's say 0 for P1, 1 for P2, process 2 for P3, for P4, for P5. Another prompt will be asked to enter the burst time of process. For P1, I'm going to prompt for P2 is 3. Let's just do this consecutively. 5, 2. Now for the final prompt, it will be asked for the priorities of the process. So basically, this is the priority part. We're going to press for P1, it's the second priority. This is the third one. No. Third priority, fourth priority. Here we have a twist. There will be two fifth process priority, and according to what I have discussed lately, if there are two equal priorities such as this number same number 5, they are going to be tied using FCFS, the first come first. So the first come is the fourth process, so this will be the first one, and the second process between the fifth priorities will be the fifth process. So once we enter, the program will start. So here the answer to our question is the average wage turnaround time of 7.6, but the table in C++ terminal might be, let's say, confused. So here I have created a table using an X is just the same, but I just arranged this so we humans can read this. We can read this and comprehend the table here so much faster and easier. So it's here, the process is P1 to 5, the burst time. Here's the burst time, 43152. 43152, the arrival time, it's the same. 01234, the arrival time. I mean, the waiting time here, it says 118004. 118004. Now, to get the average waiting time of our program, we have to add all these numbers, 8 plus 11 plus 0 plus 0 plus 4, which is 23. Now, To get the average of any number in mathematics, you have to divide it from the length of how many processes we have. So 23 divided by 5 is equals to 4.6. Now for the turnaround, here's the turnaround. So it's the same process here to turn around time. Let's say the answer is 1511 1. Let me check. Okay, sorry. 1511 156. 1511 156. This column is the turnaround time. So to get the turnaround time, same process. We are going to add the value from P1 to P5 and divide it by 5 because the total number of process is 5. Now the answer is 0.6. This column here is just the priority that we have entered from the prompt. 235 through 3455. Now, to check fact our answer, I have found this calculator from online where we just input the same similar prompt in our C++ program just to check if our answer is correct 100%. I have checked an online calculator here and wow, look at the answer. The average for turnaround time and waiting time is the same. It's 4.6 and 7.6. Also, this website has a Gantt chart here where we will verify if this is correct.
Here, in Gantt chart, it says the ABCDE. Basically means the processor 1, process 2, process 3, process 4, process 5. If we are going to explain before I created, the process 0 and it ends at time of 4. And in B, it starts at 4, it's 7. Now with that logic, I have created this Gantt chart from table with proper margin and proper lining. So the numbers it ranges from 0 to 15. Just like here in Gantt chart from the online calculator, yes, they are equal. The Gantt chart says the process 1 is 0 to 4. That's correct. The process 2, the P2 is 4 to 7. Correct. The process 3 is 7 to 8. That's correct also. From the P4 and the P5, the P5, the last part, it says that it starts at 13 and it ends in 15. Basically means the duration of these times is 3 seconds. And voila! That's all. Let's go back again here to our program. Let's have a recap, the final recap of our process management. Here is the process, the table that we have created from the C++ where we just created a table so we can comprehend and understand the table easier and faster manner. After the table, base sitting on this table, we have created this Gantt chart to verify if our table is truly 100% verified correct. And to conclude our statement,